Bahadir, Keskin.
Құрметті көрермендер, бүгін біз басқа Каспий деңгейінен 25 минут төмен ғылыми подкастымызды бастаймыз. Dear guest, today we start a new podcast with our distinguished guest, professor from Yildiz Technical University, Bahadir Keskin Bey. Атырауға қош келдіңіздер.
Қош bulduk.
Okay, Bahadir Bey is an expert in material research, in material investigations, and we would like to talk about the new innovative materials which use now. And of course, first question about nanomaterials, because everyone knows these words in the nanomaterials. What do you think? Why nano size bring so fantastic properties to the same materials when we diminish size to nano dimension?
Okay. First of all, I would like to thank you. You invite me your university. This is first time I have been in Atırau Oil and Gas University.
Welcome.
Yeah, thank you very much. I would like to see your university in what's your laboratory situation, and maybe in future we work some collaborations, some projects, I hope. So we are working on some nanomaterials. Nowadays it is very famous topic. Why the nanomaterial is important? It is new revolution. Materials, novel technology. Nanomaterial technology also is very important, but what's the difference between bulk materials and nanomaterials? Bulk materials is one size is more than 100 nanometer, but if it is between the size, one size is between 1 to 100 nanometer, is called nanomaterial. So nanomaterial has high volume, high surface area to volume ratio. That is why, because of it has very nanometer size, one size is 1 nanometer or 10 nanometer, 15 nanometer, so it gives many opportunities, many new properties of the material. So we can use this material instead of bulk materials. We can use many applications, quantum effects, mechanical strengths, and also favorable properties we can observe. When we go down in the nano scale, these nanomaterials, so they have different kind of mechanical properties, conductivity properties. So nowadays these materials are very important when we compare with bulk materials.
Yeah, so this nano, it's 1 billionth of meter.
Yeah, 10 to the power of 10 is nanometer. Is micro, 10 to the power of minus 6 is micro. So nano, it should has one size at least 1 to 100 nanometer. So we can call this is because it has a high surface area to volume ratio. In a volume you have many small size, so it will give us some catalytic effect, reaction rate increases, and many and physical properties also change when we go down to the nano scale.
So it's a very, very small size, so even the optical microscope, it doesn't have the good resolution to see it, yeah? You need the electronic microscope.
Yeah, we have nowadays, you know, why people are working on nanomaterials, because before 10, 20 years ago, the scanning electron microscope, this system just AFM spectroscopy, atomic force microscope, but it is just more than 100. But nowadays we have scanning electron microscope, high resolution scanning electron microscope. We can go around 100 nanometer surface, but also here transition electron microscope. This is the another new microscope, so we can go down around 10 nanometer. We can see what is the structure, and maybe you can nanomaterials can be 0 dimensions, 1 dimensions, 2 dimensions, and 3 dimension structures. Like graphene materials, 2 dimensions materials, and carbon nanotubes are 1 dimensional dimensions, 1D nanomaterials. So we can observe what is the thickness of the material, something like that.
So my second question about the special materials which simulate mechanical, electrical properties, MEMS materials, the so-called. What are that materials? Why they have some advantages?
Yeah, microelectronic membrane, these MEMS materials are very important nowadays, especially in healthcare mechanism. This microelectronic MEMS technology is very small technology. You can put into body some drug delivery system. You can use nanorobots or something like this. So you can observe the drug level, glucose sensor, blood rate, blood pressure, and also heart rate you can observe. So facialities, occurrences is possible with microelectronic MEMS technology. It is very important, especially in healthcare devices.
So it's a micro size, yeah, for these devices. It's not nano, it's micro size. Yeah, isn't it?
Very teeny mechanical system. This micro electromechanical MEMS micro electromechanical system, very teeny system, mechanical system integrated with electronics. There is electronic system, so it goes down, for example, skin. So under the skin you can observe, as I said before, you can observe the glucose level, something with using wireless system with your phone. You can observe your healthcare system, blood pressure and glucose level, everything. The medical system is very, very nice for this. Drug delivery system, lab on chip system. It is very simple way. You can observe your blood pressure or something, glucose level, and telemedicine applications. MEMS can be used in this kind of materials, small teeny materials. We can use it.
So these MEMS materials, they have electrical properties and mechanical properties. So they can move, they can give a charge. Yeah, isn't it?
They have own its kind of battery system inside, like
That's
supercapacitor systems. We can micro supercapacitor, something like this. Lab on a chip system is outside of the body. We can use
like
also,
plate when you put on a skin. Yeah.
and also I would like to tell you, global market is developing. It is 4.8 billion in 2023, but it will be about 7.2 billion by 2028. So it is very important. MEMS technology looks promising technology.
So it's in the next 4 years, it's growing for more than 50%. Okay, thank you very much. The previous 20th century, it was a century of semiconductors because they bring us computers so we can use laptops, all our gadgets using semiconductors. What's a new innovation in semiconductors now in 21st century?
Yeah, I am not working on quantum computers, but as I read, but you can search, people can search on the papers. So quantum technology is going. Semiconductor materials are very important nowadays. We should focus on the synthetic methods. There are some problems with high temperature. These materials maybe lose their properties, so it is very important. We are focused on doing synthesize these systems, and these are promising materials for many applications, and also with quantum mechanics, quantum computing system, it will be enhance our new future. I can tell you.
We used to imagine semiconductor and silicium,
Silicium carbide
Yeah.
is also
but
a
now
semiconductor
there are
material.
another new materials like organic, for example, perovskite materials, another like quantum dots and so on. So not only the silica
Yes.
based materials. So
Before, some carburetors are silicium carbide is the known material in this area, and also nowadays we are working on some perovskite materials, ABO3 systems. A side and B side we can change some different kind of materials. We are working on with Almaty University, some professors. We
very
have
good.
I have some students in Almaty also, PhD students, and Özkemen also. I have been Özkemen before I came here, one of. So я могу говорить по-русски and по-казахски тоже. Хорошо. Now we are working on perovskite materials also, and also quantum dot is very important material. Last year Nobel Prize goes to the quantum
yeah,
dot.
yeah.
Quantum dot material can emit light in a we want to desire in some points by changing. You can change bond energy gap ratio. So the size quantum dots means it has quantum dot. It is a dot. You can think dot, but if you change the size, it can emit light in different wavelengths. So it is very important. You can do some laser, some applications, some in physical applications, devices, and medical applications. You can do that.
So the new kind of semiconductors, they giving more smarter, smaller, more tiny.
Yeah.
So and our gadgets also become smaller and smaller and smaller.
Yes. As the technology level increases, as the some spectroscopic techniques nowadays were increasing, so people work on these nanomaterials, nanoscale, microelectronic membranes, and they are working on.
What do you think about the metals, metallurgy, metallic, new metal materials? Any some revolution in discovering new metallic alloys, metallic materials?
We also work on, as you ask, some other question. What was phytolocyanin is a semiconductor, not semiconductor. It is superconductor material.
Yeah.
You ask me. Anyway, superconductor materials is another material. So people also work on this topic. We work on phytolocyanins. It was found around 1950, but nowadays the publication rate almost increasing. It has 18p electron system. I will have seminar today. I will at 3 p.m. In the chemical engineering faculty. I will talk about this topic, and we have some publications. We can use this material in this semiconductor material. In medical applications like photodynamic therapy, and also we can use some sensor applications, gas sensor, humidity sensor applications, detection of some unwanted gases we can observe. We will have a project with Özkem and some group. We humidity sensor. I bring my sample over there. I don't know. I would like to be some project with your university also. But you should show me what is your station. Anyway, thank you.
Yeah, thank you very much. So the this new superconductors, it's metallic based, materials or
metals, alloys. Nowadays perovskites can be indium, some inorganic materials together. They make different properties, of course, but quantum dot is also very important at this point. But in solar cells, also very important when the sun is everywhere. So we should use the solar energy. And I also would like to work on solar energy, solar fuels. We say we got solar energy, and if we have some water, we can water splitting. We will obtain hydrogen energy, so we can use hydrogen energy and solar energy together. We obtain some ammonia. We can convert some ammonia. We can produce some methanol, so they can be used as a fuel. Ammonia can be used in agriculture, but in your Atrao city, I saw around there are many many salt areas, salt lakes like this, not green. So I don't know agriculture how is growing here, but some area it is very important. Not especially for Atrao, but like Özkemen and other countries in Kazakhstan. You can use this solar fuels is trend topic in 2023 in AGS, Amical Chemical Society system.
But so in Arabic countries, they also use desert for to cultivate some agriculture there, and maybe with good fertilizing, new technique, it's possible to cultivate some plants in Atrao as well.
Yes,
Maybe,
I hope.
yeah, maybe in the future. So my last question, traditional, usually, what do you think about the future of the materials, like looking forward in 5 years, for example? What happened with the new materials in the future?
Yes, graphene, we also work on many publications about graphene 2D nanomaterial. It is one of the material because it is flexible and good tensile strength, flexibility, electrical conduct, zero band gap. So smart screen and flexible screens recently in around now fold phones, we know that they are using like graphene material. Carbon materials are very important nowadays in next decade, I hope, because of also biomass and agricultural waste. We say biomass, these materials. We should convert them to carbon materials, carbonose materials, and then we can use in some energy conversion or energy deposition system. In your country, okay, petrol, benzene is very cheap, but many countries it is, for example, in Turkey, it is very high price. So we should obtain carbon materials from like waste or biomass, we say. It is very important. Also, plastic are all around. We should collect them and we should convert them to usable some new materials. And also solar energy and hydrogen water splitting energy, we should use them to convert the other methanol or ammonia systems. Also, artificial intelligence is very important nowadays. So in the future, artificial intelligence synthesis is going to be in our life. Nowadays it started because when we use AI technology, so AI synthesis, so it will reduce the time. AI will going to think what is the reaction system and what is the properties of the material. So it will give advice which reaction conditions, which material you will use it. So it will reduce the time. And also we can make big scales of the materials. AI technology is going to be our future. So some people work on this topic, maybe AI technology with synthesized computer systems. And also in your country there are petrol, some products waste outside, so it is very important carbon dioxide capture. So we can capture this carbon dioxide with hydrogen from water. We can make some organic molecules to use them like fuels or something. Anyway.
Yeah, thank you very much. So indeed, now we are coming to the century of the high-speed computer processing using big data to use the AI, artificial intelligence, the prediction and so on. So, and of course, for such high-speed processing in computers. Behind them, you see the new materials which need in the future. Thank you very much, Bahadir Bey. Teşekkür ederim.
Ben de sizge teşekkür ederim. Kazakça eğitim, ben de sizge teşekkür
Yeah.
ederim. Мне очень рад, я приехал сюда. Все хорошо. Өте жақсы болды. Görüşürüz. Sağ olunuz.
Sağ olun.
Rahmet.
Құрметті көрермендер, біз басқа апта өткіземіз.